In our last video, we wired the load instruction and store instructions to move the calculated data around. We ended up with a piece of code calculating for the first 2 rounds of the Fibonacci sequence. In this video, we will figure out how to compute for the next rounds using looping. If you like our work, please support us by sharing, subscribing, adding likes and comments. Remember, our job is to produce this sequence. This code computes the results for the first 2 rounds. Store them into the memory locations and get the 2 inputs ready in the registers for the next round. Also the memory location for the latest result and the increment. Now we're going to do the 3rd round. Add the 2 inputs in R0 and R1 to produce a 3. So another add instruction here. Now 2 is overwritten with 3. We need to store 3 to the next location. Hence, we need to increase this location by 1. But for the next round, we need 2 and 3. Now 2 is gone, but it's available in RAM, so we need to bring it over. This pointer is currently pointing at it. So before we increase the pointer, we load these 2 back from RAM according to R2. So a load instruction here. After that, we can increase the pointer by 1, and then store 3 according to the new location. Now if you compare these 2 pieces, they're exactly the same. And actually, if we were to write for the 4th, 5th, and any further rounds, you will use the same piece of code. So we need to find a way to reuse this piece of code so that users don't need to provide that many copies. Let's figure out how to do that. Remember, the default instruction execution sequence is 1 by 1 in turn. So now we need some branching instruction to break that default sequence, taking us back to this add instruction. That branching instruction is called jump instruction. It asks the users to provide the memory address of the instruction they want to go back to, and attach the location right after. So like data instruction, it takes 2 bytes, the instruction itself and the memory location. So we need to figure out the location of this add instruction, because address starts from 0. Hence, its location is actually 10. So we use jump 10 to get us back here. Now let's talk about how to wire this jump instruction. In terms of the instruction, because no registers are involved, so we can leave the 4 register bits low. Only the operation code matters. Say we want to use this 5th wire for jump instruction. Then we need low, high, low, low for the operation code. It will turn on this wire. Now let's think about the wiring. In terms of the logic, it's very simple. All we need is to move this instruction address from here into the instruction pointer, because the next instruction gets fetched will be based on this pointer. To access this desired address, we need its own address, and that is in the pointer. Because the jump instruction sits here, the pointer is pointing to the attached data. Now we can do the wiring. We need 2 steps, so 2 conditional step wires. First step, move the address from the pointer to memory address register, selecting the cell. So connect instruction pointer and memory address register. When power is on, the RAM location is sent from the pointer to the memory address register. Second step, turn on RAM to move the desired address into the pointer. So connect RAM and instruction pointer. Now after step 5, instruction pointer is pointing to the add instruction. So the next instruction to be fetched will be this guy, rather than the default next one. Let's review the little program we have now. The default instruction fetching step will make sure these regular instructions are executed 1 by 1 in turn, until this jump instruction. It will divert us back to the add instruction in the middle. Then the instruction fetching cycle takes over again, executing the following instructions in turn, until this jump instruction again. You can see how this cycle repeats itself, without requiring the users to repeat the same codes. This programming structure is called looping. But do you see a problem with this loop? It's an infinite loop. It won't stop, because every time reaching the end, it will go back. So in the next video, we will talk about how to get out of this loop using conditional jump instruction.